How sustainability and resilience are threatened by sloppy science. I'm Michael Lissack, a professor at Tongji and the past president of the American Society for Cybernetics. As we say in the United States, I need to give you a trigger warning. What I'm about to tell you is going to be controversial. I realize that sustainability is one of the major themes of this conference, but there's an elephant in the room. By me, at least, sustainability is simply the wrong goal. Sustainability suggests that what we want to do is preserve or sustain what we have right now, or at least the ideal of what we have right now. But that assumes that there's no change. I believe that what we really want is to be resilient. We want to be prepared for the challenges and changes that affect us in the future, and we want to be prepared to take best advantage of what those contexts provide. So our goal is not sustainability, it is resilience. Resilience should be looked at as a subset of the more general topic of sustainability. Resilience addresses unknown unknowns. It's about our ability to deal with the future, whatever that future might hold. To merely sustain the present, to preserve the status quo, could be to make us highly susceptible to change in the future. We don't have everything we need right now unless we are ready to deal with unknown unknowns and to be resilient. As this little chart shows, resilience is the key to a bright and prosperous future. When we aren't resilient, our recovery abilities are much more limited. We need to think about how to maximize our ability to be resilient for the future, to be flexible, to be open to what comes, not merely to sustain the status quo. But don't get me wrong, resilience itself is quite fragile. It depends on paying attention to context. It depends on trying to understand what might occur in the future. Resilience is the key to bridge the gap between the possible and the impossible, but it has to be built on a solid foundation. It can't rest on hopes, on beliefs, on dreams, on visions. It must have something solid underneath. Resilience works when it has resources, and resilience fails when it's deprived of those same resources. Resilience works best when the resources made available to it are at an optimal balance between efficiency and diversity, between flexibility and rigidness, between information and infrastructure. This graph gives you some idea of the things involved, but this is a more open question, and perhaps the question that this conference should be focused upon. How do we achieve the requisite balance, the thing that makes resilience work? Resilience depends on science, on good science, on science that is done in accordance with the scientific method, on scientific investigations that result in understanding. Resilience needs a foundation, it needs a depth, and it needs for those who are practicing it to develop an understanding of context, situation, resources, and constraints that allow them to take good note of the present and to make and ask good questions about the future. One point of this talk today is to highlight the threats to resilience that are caused by the plethora of sloppy science that seems to be haunting our present age. This chart illustrates some of the things that have gone wrong, that happen all the time: a lack of replication, a lack of adequate samples, a lack of good questioning, a lack of adequate testing. You can look through this list. Bad science, sloppy science, it's all around us. And sloppy science is a threat to resilience. The very term sloppy science came into being almost 20-something years ago, when a prominent Dutch psychologist named Derek Stapel decided that the thing to do was to fabricate data for himself and many of his PhD students. Sloppy does not refer to fraud. It was not the fabrication of the data that was sloppy science. It was the attitude of his colleagues, both in academia and in the science communities in general. They accepted the fabrication. They failed to ask questions. They failed to apply rigor. They didn't want to see what there was behind and under rocks. Sloppy science is the acceptance of shortcuts, the failure to ask questions, and a lack of rigor. Sloppy science is dangerous. We live in an environment today that is marked by great uncertainties. COVID-19 and climate change have shook up the world. With COVID-19, we have asymptomatic carriers, we have an unknown transmission vehicle, we have economic lockdowns, we have a set of governments that don't know what to do. Things are very uncertain. And with climate change, it's even worse. What do we block? How do we block it? Is it meaningful? The changes that we're asked to make today won't even show up as meaningful for 10 or 20 years. So what should we do? Humans are very bad at dealing with uncertainties. And the sloppiness in sloppy science appeals to that, because shortcuts and a lack of rigor allow certainty to appear where it does not belong. Uncertainties are not the same as ambiguities. Uncertainties are a lack of sufficient information so that there's a willingness to act. Ambiguities are when there's multiple values for the same thing. But yet again, sloppy science has a way of dealing with those ambiguities by sweeping them all under the rug. What counts is some pet theory, some overprivileged notion, a shortcut, arrived at without rigor, but asserted to be truth. Let me give you an illustration. About a month ago, I posted this little diagram that you see on LinkedIn. It has attracted more than 250,000 views, 5,000 reposts, hundreds of comments. What is most interesting is that everyone that sees it in comments seems to see something else in the diagram. They have their own explanation for what is going on. What they see is a story. They see the house, and somehow the house explains the four things before it. But with all due respect, that story is wrong. If you look carefully at the drawing, the Lego bricks are sorted by color, not by function, not by size. Somehow, magically, bricks that don't appear in the first four categories are in the final thing that we look at and say is a house. The yellow bricks seem to have disappeared. The distribution of the bricks by color seems to be very different. It is easy to look at this illustration and to say, ah, yes, the house explains what's going on. That is an example of sloppy science. You have allowed a pet theory to override your own powers of observation, and you failed to ask questions. What happened to the missing bricks? How did the color distribution change? Where did the bricks that are different shapes come from? All of that is swept aside with the notion of the house explains everything. But the house explanation is sloppy science. Resilience needs to be based on a foundation of facts, not some swamp of beliefs. It needs solid data, solid science, a solid understanding of context and constraints, and it cannot be based on just what one scientist or one researcher or one policymaker asserts is their truth. It just doesn't work. A good narrative, a good story, will dominate the headlines and dominate belief. But we can tell good stories and good narratives based on almost nothing, just based on our beliefs. And as Plato told us thousands of years ago, he who controls the story controls what happens. We need to be on the lookout when bad science, when sloppy science is providing the narratives for decision making. As I have said, sloppy science involves taking shortcuts, failing to ask questions, and not bothering with rigor. It is as if the Queen of Hearts, sentence first, verdict afterwards, has somehow taken over the notion of science itself. If you work toward a known sentence, if we work toward a known outcome, we can be very efficient. But in the process, we've adopted a set of blinders. We only see things that conform to the pre-existing sentence that we decided to impose, or to the shortcuts that we've taken, to the pet theory we've adopted, to the sloppiness that we've decided to ignore. Good science is very different. It asks questions at every step of the way. Good science accepts that any conclusion reached is but temporary. We treat that conclusion as if it had lasting durability, but it is only good until it is disproved or something better comes along. Good science depends on questions, it depends on method, and it depends on rigor. Let's talk about what it means to do good science. Good science starts when someone makes an unexpected observation. Confusion results. And good science is attempting to process how to deal with that confusion. The first question that is asked is, what should we be examining? There are many things that have been paid attention to. We have to pick out which things we're going to examine. Our attention span is limited. Our cognitive skills are limited. We cannot pay attention to everything. So the choice of what to examine is the first critical question. We then need to understand that there are constraints that have to be applied. Again, we have limited cognitive abilities, we have limited resources, we're in some kind of a context, we have some kind of time pressure. All of these things are constraints, and the constraints need to be laid out in an explicit manner. Similarly, when we go to make choices about variables, we are choosing from among some presuppositions. We ask, what is the correct unit of analysis? What kind of time period are we looking at? What kinds of relationships are we going to look at? Do we allow the subjects of our inquiry to talk to one another, or do we assume they did? Or do we assume they didn't? These kinds of presuppositions matter. We move on and we say we're going to explore relationships. What is it about the data that we've observed, the experiments we have conducted, the probing that we've done that suggests that item A is related to item B? This is the fundamental heart of our scientific query. To do this and to probe it fairly adequately, we create a set of models. The models are engaged in looking at what it means to say that A relates to B, that this context matters, that this doesn't. Models allow us to ask, what if? They allow us to make choices and to challenge things. Within the model, we will apply both inductive and deductive reasoning in order to say, this leads to that. If we do this, that happens. We begin to develop some notions of causality. Finally, when we have a good understanding of causality that backs up through many runs of the same model, we are ready to assign a label or a category and tell some narrative about what it is that we've observed. The goal of all of this was to explain or to place into context that unexpected observation. Telling that story is the key to the final step, which is then developing applications that make use of the story we just developed. This is science the way it was meant to be. Sloppy science tends to happen when two or more of the following three patterns are present. First, a reliance on truthies, on things that feel right, but are not necessarily backed up by facts or data. Second, what is known as TLDR, too long, didn't read. When the subject matter is presented in a manner where the user, the researcher, the scientist just ignores all the text and instead relies on labels, abstracts, and summaries. And third, what we call TCUSI, when things are too complex, so the researcher, the scientist, etc., made use of a shortcut instead. Any combination of two or more of these is dangerous, and any science that depends on a situation where two or more of them are present is safely referred to as sloppy science. Sloppy science exhibits itself in many forms. This chart illustrates some of them. When a scientist moves directly from making observations to telling a narrative, seemingly skipping all of the scientific inquiry in between. When the scientist disregards, or seems to at least, variables that might matter. When there's been an improper or lack of consideration of context and constraints. When the modeling that occurs is of the single scenario variety, not of multiple scenarios, not of multiple situations. When the sampling that occurs is bad or can't be justified. When there's an overuse of labels, of characterizations, of metaphors. And when the scientist is premature in applying tentative conclusions and rushing to applications. There is an irony to the idea that Stephen Colbert, one of the 21st century's great comedians, is also one of our greatest philosophers. Colbert said that a truthy is that which feels like it's right. There doesn't need to be any correspondence with facts. There doesn't need to be any deductive reasoning that says this must be true. What matters is how it feels. If it feels right, it's a truthy, and it can be treated as if it were true. Rigorous science responds to that by saying BS. But sloppy science endorses truthies. In fact, they are the path to even more sloppy science. The first time I saw TLDR was when a student announced that they weren't going to read the assignment I gave because they just didn't have time. The assignment was all of 10 pages. TLDR is laziness. TLDR is the false assumption that you know enough already that you can judge just by looking at the packaging of something whether you should bother devoting the time and energy to read it. TLDR is a major source of what allowed Stapel to engage in the Schlatter-Ventenschlap that invented sloppy science in the first place. When people are unwilling to devote time and energy to rigor, sloppy science results. Truthies were invented by Colbert. TLDR has been around for, unfortunately, more than a decade. TCUSI, now that's a new one. I take credit for it. The abbreviation means too complex, used a shortcut instead. When we read newspaper articles, in fact, when we see much of what's in the media, TCUSI rules. When politicians use memes, TCUSI rules. When our students try to explain a complex subject by citing some label, some shortcut, some meme, something that they used instead of TLDR, TCUSI is what's going on. Sloppy science allows TCUSI. Too complex, used a shortcut instead. Rigorous science forbids it. If something is complex, the complexities need to be probed, outlined, and if they're going to be cordoned off with constraints, those constraints made explicit. It is simply unacceptable to say something is too complex, so you used a shortcut instead. That isn't science. It's comedy. Or maybe, in this world, it's tragedy. Sloppy science is dangerous. Rigorous science is what we need. The easiest way to understand when sloppy science is happening is to look for one of the three T's: truthies, TLDR, which means too long, didn't read, or TCUSI, too complex, used a shortcut instead. The presence of any of the three T's suggests that there's sloppiness going on. The presence of all three of them, this isn't science. This is instead some kind of joke. The only way to do battle with truthies, with TLDR, and with TCUSI is to ask questions. Questions are the key to good science. Good scientists ask questions. Of course, question asking can take many forms. We can engage in critical thinking. We can engage in data probing. We can directly ask. We can indirectly ask. We can gather data and do statistics. We could run around and ask people what it is they think of something. We could make observations and draw conclusions. But the key to all of it is to be asking questions, not to be assuming that some pet theory, some initial idea, some truthy has its own independent meaning. That assumption is what gives rise to sloppy science. Having a shortcut may be efficient. Having a shortcut or a pet theory allows you to apply filters. If we were a designer, it allows us to work backwards. But for science, having a shortcut is a problem. What is needed is to ask what it is that makes a given shortcut work. What lies behind the shortcut? What is it that's giving that shortcut meaning? Shortcuts depend on affordances. If you remember your Gibson, affordances are joint properties of a thing and its context. In this instance, the shortcut has meaning only because of the other things that surround it. So we must ask, what assumptions are being made? What context is the shortcut being employed in? What is it that affords meaning from inside the shortcut itself? What is it that evokes meaning from outside the shortcut? And to all of this, is there some kind of knowledge that is prerequisite for us to understand? Something that comes before. Affordances, the making a possibility exactly that, a possibility, are what give shortcuts their power. But shortcuts need to make those affordances explicit. When we don't know what the affordances are, when we don't know just what it is that lies behind a shortcut, that's when sloppy science happens. That's when truthies from Mr. Colbert happen. That's when confirmation bias kicks in. That's when all of the cognitive biases that you can find on a chart have an opportunity to kick in. Not knowing what it is that allows a shortcut to have meaning and to work is what gives rise to the risk. We need to make every shortcut's affordances explicit if we're going to have any form of rigor. In the absence of that explicitness, what you get is sloppy science. Hopefully by now, you will agree with me. The world cannot afford sloppy science. Shortcuts are interesting, shortcuts are efficient, but shortcuts are dangerous. And when it comes to science, the lack of asking questions, the lack of rigor, endangers all of humankind. Neither sustainability nor resilience can be built upon a shaky foundation of sloppy science. The data just isn't there. The results just aren't there. And all that happens is we have built a foundation on nothing. It doesn't work. The time has come to say enough. We cannot accept the use of shortcuts that are not accompanied by questions, context, and some form of poking around for rigor. There simply is too much risk. Risks that in the era of COVID, of climate change, and even worse, we cannot and will not be able to endure. Unless we systematically stop the proliferation of sloppy science, our world is in danger. Our future is in danger. The time to end sloppy science, the time to begin asking critical questions, the time to teach everyone that when you see a shortcut, you must ask what it is that is behind it that gives it meaning. What is it that allows a shortcut to work? What cognitive shortcut is being taken that can be avoided, that can be explained, that can be probed? Asking questions is the key to our future. I'm sorry I could not have been with you in person. Many, many thanks for listening.